So this video, guys, is dedicated to practicing charge, specifically the charge of ions. So what I gave you in this practice, what I hope you did was complete it by yourselves, and then I'm going to walk you through each of the elements in order to convert them into ions if you're having issues with that still, which is perfectly fine, but you need to acknowledge that fact and start working on it yourselves. So let's get started. We're going to work with calcium first. And the thing that you need to do is first recognize how many valence electrons calcium has. It's the first step you need to take in order to determine the charge of each element. So calcium, I'm going to bring out my periodic table. Calcium is located right here. Alright, so it's in the second group, and remember, for valence electrons we count across. We would count 1, 2, 3, 4, 5, 6, 7, 8. So calcium has 2 valence electrons, so I'm even going to write that on my practice sheet right here. Got 2 valence electrons, okay? And so I either want to lose those 2 valence electrons, so I would go from here, I would go 1, lose 1, and then lose the second one, so I'd get the electron configuration of argon. Alright, it ultimately, guys, wants the electron configuration of a noble gas. Alright, so it can either lose 2 or it can gain 6. So it would gain 1. Remember, we jump over our middle group, our D block, so gain 1, 2, 3, 4, 5, 6. So you either want 0 valence electrons or 8 in the end. So if I have 2 valence electrons, and in the end, when I create my ion, I either want 0 or 8 valence electrons, what you need to ask yourself is, which one's easier? Losing 2 or gaining, well, I would be gaining 6 in order to get 8. Well, losing 2 is easier than gaining 6 because you want to deal with the fewest number of valence electrons. Okay, so here's the tricky part. I'm going to lose 2 valence electrons. Okay. And if you're losing 2 valence electrons, what that means is you're losing 2 negatively charged subatomic particles. If you're losing 2 negative charges, that means your ion, calcium, is going to have a 2+ charge. Alright? So that's it. Let's work on sodium. Sodium it's located right here, so it's in group 1. That means it has 1 valence electron. So you want either 0 or 8 valence electrons, so we would either need to lose 1 valence electron or gain 7. So losing 1's a lot easier, so if you lose 1 valence electron, you're going to have a +1 charge because you lose a negative charge. So it's going to be Na plus 1. Alright, and that's your charge of sodium. Okay, so if I say, okay, right, the ion of sodium, it would be Na plus 1. Okay, let's look at sulfur really quickly. Sulfur is located in group 6, right here. If you count across, that's 6 valence electrons. So it's either group 6 or 16. Either way, it's got that whole group, that whole column has 6 valence electrons. Alright? And so if it has 6 valence electrons, which I'm going to write out, you either want 0 or 8 valence electrons. Well, is it easier to lose 6 or gain 2? Because you need to gain 2 valence electrons to get 8. And in this case, gaining 2 valence electrons is actually easier. Alright? So if I gain 2 negative charges, I'm going to have a 2- charge. Alright? Okay, let's look at phosphorus. Phosphorus. Count across, so 1, 2, 3, 4, 5. 5 valence electrons. Is it easier for phosphorus to lose 5 or gain 3? Well, it's easier to gain 3 because you want to deal with the fewest number of valence electrons. Okay. Chlorine, count across, and you should get that it has 7 valence electrons. Okay, so Cl. Alright, easier to lose these 7 or gain 1? Well, it's easier to gain 1. It's going to have a -1 charge. Okay. I purposely gave a couple of transition metals because the transition metals are kind of hard to do, and I didn't, when I re-explained valence electrons in my other help video, I didn't explain the valence electrons here. So what I'm going to do really quickly, I'm going to write the longhand electron configuration of nickel, so Ni, okay, and we're going to see how many valence electrons it has. Okay, so it is 1s2, 2s2, 2p, 1, 2, 3, 4, 5, 6, so 2p6, because I've got 6 there, okay, 3s2, and I go across, 3p6, okay, 4s2, and remember the only funky thing about your D's is instead of being 4D, which you would expect it to be, your D's start on the third principal energy level. So this would be 3D, 1, 2, 3, 4, 5, 6, 7, 8. 3D8. So I'm going to write this out for you. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. Alright, now, if we're talking about valence electrons, you want the number of your valence electrons or your electrons in your outermost energy level. Well, your outermost energy level is your 4th energy level, not your 3rd energy level. Alright? Which means you have 2 electrons in your outermost energy level. Okay? Which means I have 2 valence electrons. Alright? So, interestingly, 2 valence electrons, let's talk about charge really quickly. If I have 2 valence electrons, I either want to lose 2 or gain 6. And actually, losing 2 is a lot easier, so it's going to be Ni 2 plus. Okay, so let's look really quickly. This group right here is going to have 2 valence electrons. This group right here will have 2. Alright, this group right here will have 2. This group I'm going to skip. I'll re-explain it in a second. This group is going to have 2. This will have 2. This will have 2. This will have 2. I'm going to skip this. It's an exception. This will have 2. Let's explain really quickly chromium and copper. Well, really quickly, if you look at Ti, right, still got 2 valence electrons. Therefore, titanium's charge, Ti, will be 2 plus as well. Alright, let's look at copper really quickly. If I write out my electron configuration of copper, it would be 1s2, 2s2, so 1s2, 2s2, okay, because there are 2 electrons in your 2s, 2p6, okay, 3s2, 3p6, 4s2, and then 5d9, okay? And what I explained to you guys in class, as I'm writing this, is the fact that instead of having 3d9, which is kind of awkward, 2, 3d9, because it's almost 100% filled, right? D wants 10, and instead I've given it 9. So instead what it's going to do, instead of having 4s2, 3d9, your 4s is going to donate one of its valence electrons to your D group. So what you end up with is 4s1, 3d10. Alright? So that's your electron configuration of copper. And if that's the case, if we're talking about valence electrons and you're in your 4th energy level, okay, you have only now 1 valence electron in your principal energy level. Alright, so if I only have 1, that means I have 1 valence electron, which means copper, you would want to lose this 1 valence electron, so you would have a +1 charge. Cool? So, for copper, for this group, I have 1 valence electron. And if you think about it, here's 3d4 for this group here. It's almost perfectly halfway filled. So for chromium, I'll write it down for you. For chromium, okay, it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. Now, almost halfway perfectly filled, it would rather be exactly halfway filled, okay? And so what it's going to do is it's going to take the electron from the 4s, So it's going to take one electron just like before, and it's going to give it to the 3D. So 3D is going to be half filled, and 4s is going to be half filled. So just like with copper, your chromium group is only going to have one valence electron as well. So I'm going to move this and put a 1 here. Alright, so this group will also have a +1 charge since it only has one valence electron. Okay, let's look at aluminum really quickly since I skipped it. It's your next one. You've got 1, 2, 3 valence electrons. Remember, you skip your middle group. So 3 valence electrons since aluminum's right here. So if I've got 3 valence electrons, I either want to lose 3 valence electrons or gain 5. So which one's easier to do? You're going to want to lose those 3. So aluminum has a +3 charge. And guys, writing Al3+ or Al +3, either one is perfectly fine. This right here is the convention. That's what we normally tend to do. I'm not going to take off if you write it like that. Now, if you write it like this, I will take off because I don't know if you're talking about -3 or +3. So make sure you show the plus or the minus. Okay? And that is the end of your charge practice.